Okay, let's do the next. We're gonna do this. Is gonna be the last unit for province stats. I'm gonna skip the regression this year because I need you like in person. And anyway, so we're gonna do the last unit, geometric probability. Geometric probability. And geometric probability is basically points on a line or a region um, represent outcomes. And we can expand that to just geometric shapes and stuff. But the first couple of examples will be the idea on a number line. So, for example, simply put, example one. Let's just say we have a number line and starts at 0, 1, 2, 3, 4, and 5. And so the idea, simply put, what is the probability of getting between 1 and 3? And it's just visually you can see that this region, there's 5 parts. This is 2 parts out of 5, and that's the idea. Is that you're going to be looking at number lines. So an interesting question. Let's say that the train runs every 25 minutes. Okay, and if a commuter arrives at the station, what is the probability they will wait at least 10 minutes? So this is example 1. Example 2, a train leaves the station every 25 minutes. And the question is, what is the probability that a person will wait at least 10 minutes? That's the idea. What is the probability that you're waiting 10 minutes? And something to think about. And so the idea is that I want you to think about it. Put the video on pause. Once again, the train leaves every 25 minutes. What is the probability that you have to wait at least 10 minutes? So, okay, let's come back to, so in this case, we're going to use a number line to represent this. Well, the number line is 0 to 25. So this is the amount of time you have to wait. So the train leaves, the second train leaves, you have to wait 25 minutes. So at most, you have to wait 25 minutes. So, but the question is, I want to know, you're waiting at least 10 minutes. Well, who's not waiting? Who's waiting exactly 10 minutes? Well, the person who gets there at 15. They're waiting 10. So this whole region, these people are waiting at least 10 minutes. So the answer would be 15 over 25, or you can reduce it to 3 over 5. So there's a 60% chance that you're waiting at least 10 minutes. And once again, that's the idea. Once again, you have 25 minutes. You're not at 15 minutes. That's when you only have to wait 10 minutes. So from 0 to 15, which is 60% of the number line, that's the probability that you have to wait. We could also do, geometric. When we talk about geometric probability, we can also look at. Let me erase this. We can look at like regions, like shapes inside of shapes, and then so you just have to just review your areas and stuff. The area, so we know just quickly the area of a square. Whoops. Square is, it's side by. Sorry, I'm rushing a little bit. Let's move the camera up there. The area of a square, so it's side by side, it's side squared. The area of a triangle, 1/2 base times height, and the area of a circle is pi r squared. So let's take a look at it for problem number 3. You have the square. Here's a square, and there's a circle inside of a square. I'm not the best drawer in the world, forgive me. And the region is shaded outside. Okay, and we're told that the square has a length of 6 centimeters. And the question is, you throw a dart at this figure. So you throw a dart at this figure. And the question is, what is the probability you hit the shaded region? The shaded region. Well, once again, it's part over whole. So what's the part we're looking at? Well, the whole thing, we know it's the area is 36. Well, how do we find the shaded region? Well, it's a weird shape. We never learned about it. But what we do know is that, like if we were in the 3rd grade and we're asked to, create the shaded region, we would take the square and subtract the circle. So the shaded region would be 36 minus pi r squared. So we know that if the 6, the radius is 3, so the area of the circle is 3 squared pi, or minus 9 pi. You go to your calculator, you do 36 minus 9 pi, enter, divided by 36, 21.5%. That makes sense. Let's try another one like that. This time, we're putting an equilateral, we're putting an isosceles triangle inside of a square. So let's look at number 4. Here's a triangle. Here's a square. Okay. And the height is 6, and I want to know the probability of the shaded region. So once again, it's the probability of that triangle over the probability of the entire square. We know that, so the area of the square, can you see all the way there? Of the square is 36. Let's see, we know that this is 3, this is 6, so the area of the triangle is 1/2 the base times the height, which is 9. So we have 9 over 36, which is 1/4. Interesting. 25%. So when you put a triangle inside of a square, an isosceles triangle inside of a square, it occupies 25% of the space. Let's do an even more challenging one. Number 5. So imagine that you have, let me erase that at the bottom. Let me move the computer over. Okay, let's take a look at the last one. Now we're going to take a dartboard, right? So we have a square, and we have a dartboard with 3 circles. We have the small circle, the bigger circle, and the even larger circle. Okay, and what I'm going to do is I'm going to shade it 3 different colors. So the target in the center is going to be red, and the red has a radius of 2 feet. Well, not feet. Let's just call it 2 units. So we'll call it 2 centimeters, 2 inches. Okay, and then we have the green circle surrounding it, right? The green circle has a radius of 4 inches, And then I'm going to get my blue pen, if I can find it. Oh, there it is. So there's my blue circle around here. Here's the blue circle, and let's say that this is the blue is 6, has a radius. These are the radii of 6 inches. Okay, and last but not least, let's say that the square, this is the square, it's a square with a side of 10 inches. And what the question I'd like to pose to you is green region, to make this more interesting. How do we get the green region? Because that's kind of difficult because it's not like a full circle. So any suggestions? Any suggestions? Yeah, take the green circle. So what's the green circle? It's 16 pi. And subtract out the red circle, which is 4 pi. And we get 12 pi over 100, which is, let's divide by 4, 3 pi over 25. That's the probability. We know it's less than 1 because pi is 3.14. 3.14 times 3 is like 9.42, and 9.42 divided by 25 is less than 1. We can quickly punch that in our calculators. So let's see. We have 3 times pi divided by 25. Enter. We get 37.7%. And that's geometric probability, and that's the end of the probability unit. So I'll put some homework up. You got it? Is that right? 4, yeah, okay.